Hey, welcome back to another video. In this one, we're going to kind of keep tailing on the videos that we've been doing in the past couple of weeks, talking about neuroinflammation and brain fog and all these cognitive type symptoms that can come up because of this inflammatory effects on the brain. And now we're going to start getting into what can you actually do about that. And the first thing we're going to talk about is the effects that exercise has on cognitive function. So my name is Dr. Matthew Shem. I own Peak Brain Performance Centers here in Colorado Springs. And we've been talking about how we have these different cells in our brains. We have neurons and then we have glial cells, and how the majority of the cells in our brains are glial cells being all those different types of cells that kind of help regulate the neurons and help them do the things that they're supposed to do by giving, good blood flow and oxygenation for those neurons, and also cleaning up the debris within the brain. Another thing too is that whenever you have all this excessive inflammation in the brain, these microglia are responsible for making the antioxidants in the brain that then go and dampen down the inflammation. The problem is that whenever you're under these chronic inflammatory conditions, these microglia become depleted, which means that there's not going to be as many antioxidants circulating around the brain to help dampen that inflammatory cascade. And so we talked about how this is kind of a vicious cycle and how it leads people to just progressively, continuously getting worse. We also talked about what happens whenever these microglia get primed, whenever these injuries get a little bit worse. And we talked about how on the left hand of the screen here, you'll see how these microglia have all these little feet, right? All these little feet kind of help scavenge around the brain, and it's these feet that allows it to move to go and clean up the debris. However, whenever things get primed, which you can check back into the last video when we talked more about microglial priming, but whenever these microglia get primed, now they lose their feet, so they can't scavenge as much. And so they are basically stuck in this one area and then scavenge in this one little area versus kind of surveying the entire territory of the brain. Then we also talked about how these microglia have two different states. M1 being pro-inflammatory or driving inflammation, and then we have M2, which is the anti-inflammatory. And when we're talking about neuroinflammation and glial priming, we want to get all these primed microglia into that M2 state where they're now that anti-inflammatory state. So now talking about exercise and brain health, I'm going to go through a couple articles here. This first article said that exercise is beneficial to the brain because it is associated with enhanced long-term potentiation and neurogenesis. Neurogenesis meaning the production of new neurons, as well as higher expression of brain-derived neurotrophic factor, vascular endothelial growth factors, and glial cell line-derived neurotrophic factors. Since exercise enhances the expression of growth and neurotrophic factors, which are critical for learning and memory, it is not surprising that even a single bout of exercise can also lead to improvements in these functions, being the learning and memory. In this article, they took these rats and they put them through a maze test. And what they found was that after a traumatic brain injury, long-term exercise can improve cognitive function in rodents measured by the Morris Water maze test up to 2.3-fold above their low activity counterparts, meaning they split them into two groups, one doing exercise and one doing low activity. It's interesting to note that these cognitive impairments correlated with the decrease in levels of the pro-inflammatory cytokines and an increase in the anti-inflammatory cytokines in the brains of the exercised mice. So what they showed was that in these exercised mice, that whenever they put them through these long-term exercise protocols, that they had an increase in the anti-inflammatory levels and a decrease in the pro-inflammatory, meaning the inflammatory driving pathways. In this study, they estimated that treadmill exercise provided an anti-inflammatory function by inhibiting toll-like receptors, signal transduction in response to high-fat diet by restoring normal metabolic processes, which forestall glucose intolerance, insulin test, and neuronal apoptotic cell death. So in this study, what they did is that they took these people who were on a high-fat diet, so they, eating a lot of fat and fried foods and things like that, that are naturally going to drive more inflammation, and they put them in these different scenarios where they put them in a treadmill exercise group. And they found that by doing that, it combated the excessive amount of inflammation that was driven due to the high-fat diets. In this one, they said that the positive effects of exercise have been related to increased levels of neurotrophic factors, elevated expressions of anti-inflammatory cytokines, and reduced levels of pro-inflammatory cytokines. And so just study after study telling us that exercise is basically driving these anti-inflammatory pathways and dampening the pro-inflammatory pathways, which is probably going to be beneficial. So now the question becomes, well, if exercise is good for us, what kind of exercise should we be doing? And I know that the majority of people would probably just think that whatever exercise you can do is going to be beneficial, whatever kind of exercise you can do, and for as long as you can do it. And so the reality is that it depends on you and your individual brain and the factors that are placed upon you, just like everything else in every other video that we've done, in trying to stress the importance of individualized and personalized care. When it comes to somebody that has a head injury, it's a trial and error game. And so what I mean by that is, for example, a lot of people that come and see me are dizzy or have headaches. And so with that, they may have damage to, let's say, their vestibular system or their cerebellum or stuff like that, where now they get dizzy every time that they move their head, or whenever they're changing positions, their heart rate goes sky high and it makes them really lightheaded, or maybe provokes a headache or things like that. So for those kind of people, they're not going to do a lot of exercise that requires them to be moving their head a whole lot or jumping up and down, and they might do better with a stationary bike. And so another thing to also take into consideration is that exercise by nature drives these pro-inflammatory and anti-inflammatory pathways. And so by doing this, whenever you exercise, you're releasing free radicals, which drive that M1 pathway or the pro-inflammatory pathway, but they also release opioids, which drive the M2 or anti-inflammatory pathway. And so now, again, it's going back to this like trial and error and unique situation that you have to figure out for yourself, and how much exercise and what kind of exercise is going to be the most beneficial for you. Because what they've shown is that the longer you exercise, the more inflammatory it is, because you're driving these free radicals, which then promotes that M1 pathway that we talked about before. And what would be the most beneficial is high intensity exercise. High intensity exercise really, really drives that M2 or anti-inflammatory pathway. High intensity meaning that you're breaking a sweat, that it's difficult for you to continue holding a conversation because your heart rate is going so fast. So what I typically recommend people to do is start out at just a couple minutes, depending on the severity of the head injury. Let's just say head injury, because most people that see me have a head injury of some sort. So with that, I typically start out, let's say 3 to 5 minutes of a really high intensity exercise, and then kind of monitor how you feel. And as you go throughout the day, you should start noticing that you feel this more clarity or less brain fog, and you feel sharper and your memory is a little bit more clear, all these different things. And then what you're going to do is, let's say that you did 5 minutes on your first round. Tomorrow, I would say bump it up and do like 7 minutes and just kind of see, how do you do with 7 minutes? And then try to gauge up as high as you can. And let's say that whenever you get to 10 minutes, you start noticing that it's just taking too long for you to recover from that much exercise. Your brain doesn't feel as sharp as it did whenever you were doing 7 minutes. And so again, this is just that trial and error thing. 7 minutes was pretty good, but 10 minutes was too much. And so we back down to 7 minutes and we just continue working there. And maybe you notice that if I do 7 minutes of high intensity exercise in the morning, I notice this real sharp clarity in my brain, but it kind of tapers off at the end of the day. And so maybe instead of just doing one session of a high intensity exercise, I'll do 2 sessions in the day. I'll do one in the morning and then one at night. So it's just a kind of a trial and error, a guessing game. And this is why it is so important that you find a provider who is not going to put you in just this cookie cutter mold that they do with every single patient, because the reality is that we're all different. And what works for you may not work for me, and what works for me may not work for you. And so with that, I hope that you learned something. I hope it was interesting. If you have any questions, feel free to email me or give my office a call. And other than that, I will see you in the next one.